Welcome. In this video, we'll learn about the basics of structured query language SQL. Please watch the video till the end because we'll be covering all the fundamental commands and how they work. Okay. They are very important. So what is SQL? You already know. It stands for structured query language. It's a standard language used for relational database management system to access, manipulate, insert, delete, and all those things. Okay, manipulate, define the structure, manipulate the data, and for querying for the data. So SQL is a non-procedural language, that is, it's a declarative language where you'll only say what you need, will never explain how to get the data. Okay. One more important thing is, unlike other programming languages, SQL is generally case insensitive for keywords, table names, and attribute names. Okay, for example, if you have a SQL select command, so I can write like this also, I can write in caps also. So case insensitive. It takes both. Even it applies for names of the tables and the attributes or column names in the tables. But string values are case sensitive, but depending on the settings we make in the DBMS. Okay, so DBMS software, the different correlation settings there. Based on that settings, the string values can be case sensitive or insensitive. Now we'll see some of the basic data types in SQL. So these are the building blocks for your SQL queries. So first one is the character. So char n means it's a kind of n characters. So it is a fixed length string. Okay, there are two types of strings that are possible. Okay, in SQL using char and variable char. Okay, var char. So here what is it is fixed length. What happens if I specify say char 10? So all 10 spaces. Okay, all 10 locations in the memory will be used. When my string is say only 4 characters, rest all 6 characters will be added with the spaces. So it is not an efficient way to utilize the memory. Whereas varchar, the full form, you can also write it as character n, or in short, you can also write it as char n. Okay, n is the number of characters you want. Varchar is a variable and character string. It just works like character. Only thing is, so whatever locations in the memory I have declared, if I'm using them, only that much of memory will be allotted. For example, varchar, if I say varchar 10, okay, so 10 locations will be given to me. However, if I store only say 4 characters, rest characters will not be appended or added with 0. So it only stores the actual values, whatever I put. So it saves the memory. So full form is character varying n. So in short, we usually use varchar n. Then for integer data types, you have data types like int and integer. Both are same. Stores integer values. Range depends on the system architecture, whichever database you are using. For example, Oracle or MySQL. Based on that, integer value differs the range. What is the maximum? What is the minimum value it can take? It also supports small int. Okay, so you just reduce the size of the integer storage. It's a subset of integer. Requires less storage. Then you want to represent exact numeric data type. Okay, the exact numeric data type means I know the particular value. So for example, say 44.5. So then I can use numeric. So the syntax is numeric in bracket p comma d. See, p indicates total number of digits, precision, and d indicates digits after decimal point. So this precision p also includes the d. So for example, if I write numeric 3 comma 1, if I declare attribute or a variable with numeric 3 comma 1, so for example, it allows 44.5. It will not allow 44.5. So this 3 means what? So 2 digits before the decimal, and then 1 digit I can use after the decimal. Okay, so that is the meaning. This is used where exact numeric accuracy is required. So for example, when you want to round off, in a GATE exam, for example, the numerical answer type, they will mention the exact value, 2 digits, 3 digits, okay, after the decimal point. Then if you have variable numeric values, so approximate numeric values, just like your programming language like C programming, you can use float double precision like that, single precision, double precision. So single precision is usually a floating point. So it is machine dependent precision. Double precision, floating point values, higher precision than the real values. So real is a data type indicating float, just like your C programming. Double precision means it is double. Okay, precision is double. Number of bits given for double precision is more than real. And then you can also have float n, okay, where n digits of precision is required. These are different data types for storing floating point numbers. Then there is something called as n varchar. Okay, so variable length Unicode string. See, for example, if I want to store a data, specifically we design the databases are designed for English language, right? They're English language. Now we require for certain applications for different countries. In our country also we speak different languages. Okay, like for example Hindi, okay, Tulu, Kannada, okay, Tamil, Telugu. So there are different strings. There are different letters used there. How will you represent those data in your database? For that, you usually go for Unicode standard. Okay, this is a multimedia standard, Unicode standards for characters. So for such kind of data I want to insert, use n varchar. So it supports multilingual characters used for international text storage. Then null values in SQL, we will make a separate video on this because it requires a lot of understanding. So in basic data types, null value is also represented. What exactly null means? It can be a missing value, unknown value, value known, not yet recorded. Okay. So meaning of the value, meaning of null means what? Value may exist but unknown. Value may not exist. So columns can be restricted using not null. So if I want a particular value to be present in that column, so I can make the column in the definition as not null. So I have to definitely insert a value for it. We will all see the structure shortly. Now, how will you design a basic schema? So schema means it's a structure of your database, the collection of your tables and how they are interrelated using primary key and foreign key. What are the constraints you put? So entire thing, the structure we call it as a schema. So how will you define? So you to create relations, so we also call them as tables using the create table command. Okay, create table will create me what? This is SQL command used to create a table. So it should be followed by the table name. For example, create table student. We'll see the example. And then you have to define the attributes, that is columns of these tables. Okay, for example, student ID. And then what is the data type of it? Student ID, say, let us say varchar 10, comma. Comma indicates there is one more attribute to follow or one more statement to follow. Some name, say varchar 30. Then say marks. I can take it as int. Okay, so if it is a last statement, I will not put a comma here and just end it and then end the, open the bracket here and then close the bracket here and then end with semicolon. So in some systems, some DBMS system, semicolon is not mandatory, automatically it is a semicolon. Okay, but syntactically, when the SQL was initially designed, we use semicolons. But, so in the create table also, we should mention the constraint. It helps us to mention the constraint. For example, which one is the primary key? How will I mention? Which one is the foreign key? If it is not null, so particular attribute, for example, name, I will make it as a not null. If I write like this, it will, so whatever, if I try to insert null for the name, when I insert the data into this table, it will not allow. Okay, unique. So the values must be unique. So we'll see those examples one by one. So now how you create? So create table and then the table name, okay, relation name or table name. Then the attribute 1, 2 represents what? Your column names. So you are just defining like this. So this the relation name, the entire table name or table name. Then you have the columns or attributes in your table. So these are defined like this: attribute 1. So this is a attribute 1, attribute 2, attribute 3, and then this data type indicates the domain of this attribute. Is what is the data type and what are the possible values the attribute A1 can take. Then the constraint. For example, if I want to make this A1 say as not null, you can add here not null like that. Then at the end you can have the table level constraint. That means I want to make this A2 as primary key. I want to make A3 as foreign key referring to other table. So those are the table level constraints. So all things are put in the create table structure. I already know the purpose of the constraints. So these constraints are used in for accuracy and consistency of the data. Already discussed this in the ER model, ER data model. What is the primary key? Uniquely identifies each tuple, cannot contain null values. So these are the integrity constraints. Foreign key references primary key of another table, maintains referential integrity. Not null prevents missing value. Composite key consists of multiple attributes. Now how can we add them in our SQL using SQL? So let us create a table, say department table. So create table department. So this creates a table structure named department. So it's a logical structure. See, the database, it is not stored like a table inside the file system, but for logical view it is shown like this. Then I'll create the first column department name. So department name. Then I will create building. Then you have budget. So you are also mentioning the domains. Domains is the data type varchar 20. So this can take strings kind of values and maximum size is 20. The range. So building varchar 15. Budget numeric 12, 2. And then we are adding a constraint here. Table constraint, that is primary key. This is the syntax. Primary space key is the keyword. Primary key, and then in the bracket mention which attribute you want to make the primary key. You can also add multiple attributes here. So department is the what I am making. The department name is the primary key. Now I will create a course table. So course table is now referring to department table. Okay, what department this course belongs to, who handles this, which department handles these courses. So let us create table course ID varchar 7, title varchar 50, department name varchar 20, credits numeric 2, 0. Now in this table I am making primary key the course ID as the primary key. Now this course depends on the department, which department handles this particular course. So for that I will add foreign key. So from this table, which one is the foreign key I want to make? So this department name is the foreign key I am trying to make. Now once I make this foreign key, this has to refer to the primary key of the some other table. So for that I have to write references. Foreign key department name references. This is a keyword. The department table in the same database. Department table present in the same database. And in that department table, department name is the attribute which it has to refer. So department name in the previous example, you have made it as the primary key. So that is now the course table. Course table is now referring to this. So department name here is referring to this. This is now acting as a foreign key here. Okay, so note that you can have the same names in different tables. Okay, that doesn't matter. Only thing is when you combine these two tables, then there will be a ambiguity. Then we'll see how to resolve that ambiguity. Now, how will you insert the data into your tables using SQL? So for that you have the command insert, SQL command insert. So syntax is fairly simple. So there are two forms you can use. One is insert into table name followed by the attributes of the table. They need not be in the same order. Whatever attributes you mention here, okay, there is a table, say A1, A2, A3, so on. Now when I insert this, I am saying in this order only. First A1 value, second A2 value. So here whatever values I insert, V1 here will go into A1 column. That is the meaning. If I make it A3 here and insert V2 here, V2 will come here. That is the meaning. So insert it without attribute list. Let us not mention this attribute list. In that case, what happens? Whatever is the predefined order A1, A2, A3, whenever I created a structure, when you created a table, there is a predefined order of attributes are created. So it directly default it inserts in that order only. If it is A1, A2, A3, then V1, V2, V3 will be inserted directly in that order. So key rules for insert. The one thing is values must match attribute data types. Okay, for example, what it means is if I have integer, a marks as integer, I have defined the marks column as domain as integer or data type as integer. Now I cannot store marks equal to say some string xyz like this. That's what it means. So it violates domain constraint. It will not allow you to insert. Order must match the attribute order if column list is omitted. So in the second type you have seen this one, is a column list or attribute list is missing. So in this case, you have to follow the particular order how you have created the table. String values are written inside the quotes like this, x, y, z. Numeric value is written without quotes, so 10, 20 or say 10.23. Missing attributes receive null value. Null is the keyword in SQL. What are the constraints you already seen? Primary key must be unique and not null. Not null attributes must have values. Foreign key values must exist in parent table. If foreign key value is missing, insertion fails because we are referring to the parent table. If there is no tuple or no value for the primary key and then you are trying to insert that value in the child table, it will not allow. So that is the referential integrity constraint. DBMS enforces data type and size limits. Now, when it comes to data insertion, to maintain the integrity constraints, what should we do? Insertion order with the foreign keys matter here. See, for example, previously already was seen the department and the course table. Okay. Department is a parent table, course references department, and then section refers course, enrollment refers section. So that means what? If I want to insert data into enrollment, if I want to insert data into this table, enrollment table, then this table is referring this section table. So first this table has to be filled. Now this section table is referring course table. So first this has to be filled. Then course table is referring department. So first this has to be filled. So the order in which how you insert data is first department, then course, then section, and then enrollment, because there is a primary key, foreign key relationship between them. So for example, so there are two related tables. Department is the parent table, employee is the child table. So here create table department, department ID int primary key. So here also I can mention the constraint. So department ID I am making a primary key. Department name, varchar, and then budget. So 3 columns in this. Then I have created another table, child table, employee. Here employee ID is the primary key, you have employee name, and then department ID. This department ID is the foreign key. Okay, this is referring to this department ID because I am making it as a foreign key. Foreign key, department ID, references department, department ID. Okay. Now when I insert the data, I cannot insert directly into employee, because when I insert this department ID value in the employee table, for example, say I want to insert 10, department ID 10, that 10 should first exist here. Otherwise, I cannot insert it here. That violates the integrity constraint. That's what the insertion order is. Always parent table has to be inserted first. So I'm inserting 10, 20, 30. And then I can insert by referring to those values 10, 30, 20 I'm inserting. So these 10, 20, 30 should exist here. Okay. If they exist here, because this is the primary key of department, I am referring it here. Okay. So those values should exist in the department table. Otherwise, I cannot insert. So for example, insert into employee values for Kiran 99 70,000. See, this is nothing but department ID. This insertion fails because in our original table, department ID 99 is not there. Is not there. So it is not allowed. So DB checks foreign key department equal to 99. No matching value in the department table. So insert is rejected. Row is not added to the table. So insert using column list example. So insert into employee, employee ID, employee name, salary and department ID. So I have changed the order here. You see this, my department ID, employee name, department ID and salary. This is what is the structure we have created. But I can just change my attribute order. Okay. I can change attribute orders and then insert in the same order the data. Otherwise, to insert swap these two, then it will go here and here. Okay. So column order you can change. Some attributes may be skipped if they are not null. Therefore, when table has many attributes, it's better. If you have 100 columns in your table, then you cannot name all the columns. So I am without attributes. If I take it, I don't know what data to insert, which column is what. So if I want to insert only out of 100 column, only 10 columns or 5 columns, I can just mention those 5 columns and then insert the data. It will be easy. You can also do at a time multiple rows, insertion of multiple values, multiple rows. To insert into department values. So you can use comma for each tuple. This acts as each tuple and end with the semicolon. So at a time you can insert 2 or any number of rows. So insert into table name, then values, followed by each row separated by a comma value. You can also insert with arithmetic expression. For example, here salary is a salary attribute. I can use what? If it is integer type, usually we can do arithmetic operation. For example, I am doing here plus, minus, into, division, whatever you can do. So, and as long as the domain matches, the result should have the same domain as the attribute. Then I can insert like this. I can also use the expression in the insert. So arithmetic expression evaluated first. Result stored in the table. So here the salary is stored as what? 55,000 after addition. Now we'll see definition and modification commands. So there are different commands to modify your data in the tables. So first one is the delete. Then you can update your table. Delete means deleting the data from the table. Updating means updating the structure, updating the values in the table. Alter means updating the structure of the table. Drop means delete the table. Truncate means only delete the data, keep the structure as it is, keep the table as it is with empty, as empty. Now we'll see one by one. So delete is the one of the most important thing and frequently asked in the exam when it is associated with the referential integrity. We'll see those examples. So delete command is simple. So the command is delete and then from is the keyword. So delete from the table name. Delete from student where department is equal to physics. So if it was the initial table, there are 4 rows here. And then I'm selecting that row. Where condition is used for what? To check the condition where department is this column. Where department is equal to physics in single quotes, physics. So I will select, I'm selecting this row actually. So what we are doing basically is we will be selecting the columns, we will selecting the rows, filtering the rows. That is what is SQL all about. How to get the particular data or insert the particular data. So once I select this, I am going to delete this row, entire row. That is what it means. So the result you can observe here. And then this is also selected because there are 2 rows with department equal to physics. So both rows will be deleted from this, from the table, and this is the result. Now what happens if I don't use this condition? Delete from student. That means what will happen? So all the data will be deleted. Only data, table will not be deleted. All the data will be deleted. But however, it is subject to the constraints. If someone is referring this table, then I cannot delete those things. Okay. So there are different things that we will see shortly. Now, constraints on deletion. Okay. When a row in a parent table is deleted, the DBMS must ensure that no invalid references remain in related tables. If another table contains a foreign key referencing the deleted row, the database must decide what to do. Okay, this is the problem with the issue of the referential integrity in delete. You already know there are 2 tables, a department and then the employee. Department ID is the primary key here, and this is being referred by this, okay, as the foreign key. Now the question is, if I'm using say department ID 10 here, so 10 is a key here and there is a row with 10. If I delete it here, what will happen here? Okay, that is the question. Is this allowed to delete? Okay. Now if I change this value here to 20, what should happen here? How will you do it? So that is the constraints on deletion and updation. Okay, so there are three policies we use in SQL. Deletion policies for foreign keys. When a reference row is deleted, the DBMS can apply one of the following rules. One is restrict. It is a default case. Deletion is rejected if the related rows exist. Fails if instructor belongs to CS. For example, say that there is a department, okay, department ID and then department name. So 1 and CS is the department name. For example, this is being referred by say some instructor table. He is using this department ID. If that employee ID, so 1, say department ID 1. Now, if I delete this, because there is some instructor who belongs to CS, there are some instructors who belongs to CS, they are using this value. So by default, restrict means it is not allowed to delete, cannot delete it. So it is a default case. And the second one is cascade, deletes the referencing rows automatically. Deleting department deletes its instructors also. So for example, if I delete this, the cascade case, on delete cascade. So if I delete this, so it will be deleted. And then whoever is referring here, okay, whoever is referring 1 here, will all those rows be deleted. All those rows will be deleted. So this is on cascade delete. And also other tables who are referring this, okay, value, those tuples will also be, rows will also be deleted in those table. Then the other thing is set null. Foreign keys value in referencing table become null. Instructor still exists, but department becomes unknown. So for example, what I can do is we can set it to null. For example, if I delete this row, then I need not delete this employee record here. I can just set it as temporarily department as null. So currently that employee belongs to no department. The department doesn't exist. So in future, we can add him to the new department. That is the meaning. So cascade and set null. We'll see the examples one by one. So how you actually create these constraints? How will you add this conditions? So when you create the table itself, you have to add the conditions. So create table instructor. When the instructor is created, in our previous example, so he is referring to department name of the department table. Okay, department name, the department table. Now on delete cascade means what? If this department name and department table is deleted, I will also delete my entries which takes this department value. For example, CS. If I'm taking CS value, if CS row is deleted in the main department, this row is deleted with this department name, then whatever data I am having in the instructor table for as a foreign key CS, that rows will also be deleted. That is on delete cascade. On update set null. Okay. So if there is any change, or deletion, I will try to set that value to null. Okay. To set that value in my table, in the instructor table, or the referring table or the child table to the null. So for example, if department name changes, instructor.department become null value. Okay. So for example, say that department name CS Maths Physics. Okay. And then I am referring to this department name. So this is the key here. CS Maths Physics, 3 departments are there. There are 2 instructors, Alice, CS, Bob, Math. Now, initial thing is restriction. I have not given any on delete cascade or update. So delete from department where department name equal to CS. This deletion will fail because in this table CS is being referred, okay, using the department name of department table. So this will not be allowed because this value here we are referring. So that is the default behavior. Now deletion on cascade. Delete from department where department name equal to CS. So in query is the same. Only thing is when you created a structure of the table, so this whatever we mention here, this or this. So based on that, your execution will take place. The deletion execution will take place. So what will happen now? So delete from. So if I try to delete this row, what will happen? The result will also delete this row because this CS is being deleted here. Okay, because it's the foreign key. Hence, this row will be deleted. If there are multiple rows using CS as a department name here, all those rows will also be deleted. If there is any other table also using CS as the foreign key, then that rows will also be deleted. That is the cascading. Then delete from department where department name equal to CS. Now say that if I change something, say CS to CSE, if I change the department name here or delete it, then what happens? I'm setting it as null. If there is any change, you set it to null. So instead of deleting this row, okay, I will set this department ID to name to null. As long as the department name is not given not null. In the definition of your table, if you make this department as not null, then I cannot put it here. So you should not use this constraint not null to make sure that the foreign key can be null. Next is updating the data. The update command is used to modify existing values in the table. What is syntax? Straightforward. Update followed by table name, then set is the keyword, and then attribute or column name equal to value. You can use multiple updates at the same time and then use the where condition. If this condition is missed, okay, condition means what? You are selecting a particular row or set of rows. If you won't put any condition here, okay, you won't put any condition here, what will happen? It will update all the rows for those particular columns. Okay, so be careful when you use update command. Updates one or more columns in existing rows. Where clause specifies which rows to update. If where is omitted, all rows in the tables are updated. Multiple columns can be updated in single statement. Can use expression or values from other columns. For example, update student set marks. Marks is the column name equal to 85 where name is equal to Neha. So first we will select the column, which column to update. Then we have to select which rows to update. So I'm selling condition name. The name is equal to Neha. So this row will be selected and then this value will be set to 85. What happens if I remove this condition? Means what? Select marks, update students. This marks, update this column marks equal to 85. Then means what? I'm not putting which row. I'm not putting which row condition, selecting which row. So what it will do? It will change it to 85 for everyone. Okay, so always you should be careful to mention the conditions. Next. If you want to change the structure of the existing tables, you already created a table and tomorrow there are new requirements, so you have to sometime update the tables. You need to add some new columns, okay, new attributes to your table, or you want to delete some tables, or you want to change the data type of the table. Then you can use the alter table command. Alter table followed by your table name. You want to add a column. Add is the keyword. New column name, then what is the data type of that column. So for example, the initial student table, I want to add a department table. So department column or attribute to this here. Now alter table student add department. This is the attribute name and data type is varchar 20. Okay. So where you want that also you can select. I cannot include those examples here. Suppose I want after the name itself, I want department name. Okay. That also you can do. So you can, there are different syntax you can see. But only we're interested in, so alter what alter does. Okay. So once it creates, see, we don't have the values for this, existing values for this. Okay. Existing values for this rows. So it will initially set it to null. Right? Later you can update it using update command. Then modifying the column, existing column. So for example, I want to change the data type. Alter table, table name, modify column name with new data type. Okay. So here I am adding the column. Here I am modifying the existing column. So for example, I want to change the data type of the age as int. So initially assume it was numeric. I want to change it to int. So alter table student, modify age and give the data type int. So it will change it to int, but there will be no change in the values here. Whatever I am changing here, modify, so this should be compatible. So I cannot make a string and then go make it as integer. So domain violation happens. Next, you can also drop a column or set of columns. Alter table, table name, drop column. Drop column is the keyword followed by column name. Alter table, student, drop column, department. So initially department was there. The entire column with data will also be removed. Okay, so there is no department here in the output. Then drop table. If you want to drop the entire table, drop table student. So everything will be lost. Okay, so including data and the structure. Table structure is removed, all rows are deleted, so table no longer exists in the database. Then truncate table. If I want only data to be removed, the structure, the table should be as it is. So that means what I have to only remove this data. Okay, the structure should be there. So I can use truncate table and then followed by table name. So student table, if I use truncate, so there will be no rows in the output, only structure will remain as it is. Now we'll see the basic structure of querying, how to select the data. So for that you use the select command. Okay. Select command actually selects the columns of the attribute of the table, selects the common columns, and then this where condition actually selects which rows. Okay. So it's all about rows and columns. Rows, this is columns, and this is about rows. And from means which table, which columns from which table and which rows is the meaning. Select attribute 1, attribute 2, any number of attributes I can give from table name where it specifies the certain condition. So duplicates allowed by default. So if you compare with the relational algebra here, so in the relational algebra by default the duplicates are removed, but in SQL whatever result I get as the table output as the relation or table, always the duplicate values will be given to you. If there are two persons with same name, both will be included in your result. But in case of relational algebra, it is not so. Okay. So in relational algebra, we say select like this. This actually selects the rows. Okay, that is just the reverse of SQL and relational algebra. Don't get confused. There in relational algebra, select means it's a condition, selecting with some condition, and then projection means actually select there, projecting attributes, columns, selecting the rows. Okay. What is the difference between array and SQL? If I want to select all the columns, I can just use asterisk. Okay, select star from table name or select asterisk from table name. It will select all the columns and all the data, all the rows. So star means all the columns and all the rows, entire table will be displayed as the output. Now, the most important thing is renaming, also called as aliasing. So you can change the rename. So in the relational algebra, you see rename operator. You rename the tables, you can rename the attributes. Because when you use some self joins or self products, we have to rename them. So that is as is the keyword used in SQL. Select t dot column name as new name from table name as t. Okay, see what I am doing here is initially table name was given some name and then I am renaming it as t. So I want to change some attribute. The t dot column name, t because table name, initial table name as new name. So for example, say here I have employee ID, name and salary, three attributes in employee. What I am doing here, select e dot name as employee name. Why I am writing e dot name? We'll come to that later. First here, e dot salary as as income from employee E as E. So I'm renaming this as E. Now this becomes E dot employee ID. So when I have the ambiguity, I told in the beginning, when you have the ambiguity, then I have to use the table name. For example, I have department table and student table. Here also have department ID and say I have foreign key, department ID and student table. These names are allowed, but when I select something from select DID from both the tables, so there is ambiguity. Which DID I am referring, this DID or this DID? So at that time, what we will do? We will take the complete name. So for example, department dot is the operator dot DID. This indicates what I am referring to, department ID. Then student, I can write it as student dot DID. This represents, I am referring to this attribute of student. So here in this example, I have renamed this employee as E. So I'll write E dot employee ID, E dot name means the same. So I have renamed it E dot salary. Employee is, the table is renamed as E in short form. And then from E, I am fetching E dot name as the employee name. So instead of writing E dot name in the output, I will rename this to employee name. So for that, I am using the as keyword. Okay. You can also omit as. Okay, just you can write, say for example, select say salary from employee. You can write as E or just E followed by this, for example. Then it will rename. So as can be used or just without as also I can use in the SQL. That is about the renaming. Now, just like your other programming languages, you can also use your logical operators, arithmetic operators, comparison operators, and all those things, logical operators. So there are equal to, this indicates not equal to, okay. And some modern RDBMS also supports not equal to, just like your C programming or Java programming style. This is greater than, less than, greater than or equal to, less than or equal to, and then you have between. Okay. Like column is, okay. We'll see one by one with examples. So select name salary from employee where salary is greater than equal to 70,000. So salary greater than equal to, so I am selecting what, name salary. So I am selecting these two columns first in the output. Then I am putting the conditions on the row using the relational operator greater than or equal to, where this column values are greater than or equal to 70,000. So this will be selected and this will be selected. And then only these two columns are selected for the output. So this is the output. This is how it works. You can also use arithmetic operation in select. You already seen this. So select column, column plus value, column minus value, column star value, column divide by value, so on. For example, select name salary and then salary into 1.1. So increment 110% as new salary from employees. What I'm doing, initially this table is name salary. So I'm creating it as name salary. Same thing I'm taking, and then I'm creating new display attribute. Okay, where salary is 1.1 times the existing salary. So multiply it by 1.1 and then store it as new salary. Okay, but the table structure will not. Okay, this is only view. Call it as a view. This is how it is displayed in the result. Okay, but the actual table will be like this only. There will be no change in the table data. Then logical operators. You have and or. So select columns from table name where condition 1 and condition 2. So for example, where salary is greater than 60,000 and salary is less than 80,000. So we will select what, name and salary, both columns are selected. Then what is the condition? It will see all the salary greater than 60,000. This is greater than 60,000. Okay. And it should also be less than 80,000. Greater than 60,000 and less than 80,000 is 55,000 and 70,000. So only those two rules will be selected because it is AND. Both conditions should be true. 1. or. Or means either one should hold, it will be added in the result. So greater than 75,000 or less than 60,000. So greater than 75,000, this is selected, and then less than 60,000, this is selected. So 80,000 and 55,000. Now there is a keyword called a distinct. So as I told you in select operation, even the duplicate values will be displayed, unlike your relational algebra. In relational algebra, duplicate values are eliminated in the projection. Here in the display, duplicate values are displayed. So if I want only distinct values, that is unique, okay, no repetition, then I can use distinct. Select distinct followed by column name from table. So for example, this is the salary table, so only one column. So here 70,000 is repeated twice. If I use just select salary from employee, then this will be the result. But if I want only unique values to be displayed, 70,000 as only once, then I should use distinct salary from employees. So 70,000 will be displayed only once. The next important thing is pattern matching. So there is the operator called as like in SQL. Like helps us to match the string patterns. For example, a query select column from table name where column like some in single quotes will write some pattern. This is pattern matching. So there are two patterns. One is %, another is underscore. Okay. Percent matches 0 or more, like a wild card, 0 or more. Underscore exactly one character, exactly one character. Okay. So for example, say that select building from building where building like % Watson and then Watson. So what exactly this means? I am selecting this building and I want to select those rows, filtering those rows which contains Watson. See, in the beginning, % means what? 0 or more characters before this string, 0 or more. After that also 0 or more. That means what? I'm just finding the string or the building name which contains the keyword Watson, contains the string Watson. Okay. Starting with, for example, if I want to find names of the buildings which starts with Watson, not containing. So start with Watson, then followed by 0 or more characters. It can be there or not there. Okay. So for example, this will be match. This will be a match. Ends with. So whatever may be in the beginning, it should end with some particular hall. For example, say example hall. So Watson, so 0 or more character matched. Okay, then hall, this will be selected. This will be selected. So that is the answer. Using single character underscore. Okay, so for example, select course ID from course where course ID like CS10, only one character. Whichever is starting with CS10 and ends with only one character. If there was say 1010, this will not be a match. Exactly one. So one can be there here, two can be there. So this is the single character. If I write like something like this, like where name like or course ID like for underscore 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 and then say 5 underscores. So it should exactly match 5 characters, whatever may be the characters, 5 characters including spaces. So this one, and this one, all 5 will be matched. So say that it was here like this. So this two will not be a match. Only exactly 5 characters it will match. You can combine underscore and then this to form different patterns as pattern matching to find the particular strings in your tables or rows. For example, where column like A underscore underscore, that means what? You should begin with A and should exactly have 2 characters after it, exactly 2 characters after it. So A is the first match, this also matches, this also matches. Then after that, Oshi, exactly 2 characters. This will only the match. Here are 3 characters, here also 3. So this is not a match. So answer will be only a V. The next is the between operator. So column where column between the lower end and the higher value. Okay, so it is equivalent to what? Greater than or equal to. So this high value and low value both are including. It is not something exactly in your mathematics. Okay, in mathematics, open interval, close interval is different. Between is really we avoid the last values from the right side. But here both values are inclusive. Okay, if I say greater than or equal to 80 and between less than or equal to 90 is same as between 80 and 90 means the same. Okay, so range is inclusive of both the sides. Works on numbers, dates as well as strings. Improves readability of SQL queries. For example, select name from instructor where salary between 90,000, that is greater than or equal to 90,000 and less than or equal to 1 lakh. Okay, that is the meaning here. So you select all those. So this is this and only two. So I am selecting only those names. That is the output. You can also write using and also, where salary is greater than 90,000 and salary is less than or equal to 1 lakh. Same thing. Similarly, not between, other than these two. Okay, not between this range, outside this range. Okay, so what are the answer? Not between 90,000 and 1 lakh. So not between 90 and 1 lakh are Ravi and then Kiran. Then the next is row constructors or tuple values. You can compare multiple column values together. For example, you can compare A1, A2 equal to B1, B2. So I'll show you an example. For example, say that select name, course from instructor and teachers. Okay, I'm taking the Cartesian product. In the next video, I'll understand the joins. There I'll explain. So from both the tables, I'm selecting name and course by taking the product of these tables. Where condition, if you observe this we are interested in now. Instructor.id, that means this one, comma department. Both I am trying to compare together. That is equal to teachers.id, this ID, comma boards. Okay. So that means what? If instructor ID and then the biology is there, you then match that, equal to will be true. You select that row which matches together. Okay. So for example here, raw and biology. Okay. Because here instructor ID is I1 and then department is biology. Then teacher's ID is 1 and then biology is what I am giving as a string here. So it exactly matches. That is instructor ID is I1, comma, department is biology. It is coming from this row. This is equal to teacher's ID is teachers.id, say I1, comma, biology is the hard code string I am giving here, biology. So this is equal, so this row will be selected. That is the meaning. Because I'm selecting the course in the table output. Okay, that's why it is displaying this value, whichever is there is a match. The next is order by clause. If you want to sort your data in the columns by ascending or descending order, you can use the order by. Select attributes from table list where condition order by attribute list controls the order of rows in the query result. Default sorting is ascending. Always it is in the ascending order. Sorting can be done on one or multiple attributes. Only affects the display result. How you displayed logically it is affecting, but not exactly the how it is stored in the database. Can be used with expression and aliases by renaming also, and you can also use the expression in them. So ascending and descending, ASC and DESC are the keywords. ASC stands for ascending, DESC stands for descending. So order by column ascending, order by column descending. So that is the meaning. Multi-bit attributes also can be used. We will see an example. Sorting evaluated left to right. Next attributes resolves ties. Okay. So for example, select name from instructor where department equal to physics, order by name. So what I am doing here is ordering based on the name. Okay. So what it is selecting? Selecting name from instructor where department is equal to physics. So this is selected. These two are selected. Order by name. So here Anil and then Kiran. Sorted on the name. Next. Want them to display in descending order. So select name salary from employee, order by salary descending. So first from this table you select name and salary both attributes and then display result as ordering by this descending order, that is 90,000 should come first. So Neha 90,000, then this, and when you order a column, so every entire row will change, okay, not only those column values. So whichever you're displaying, all those will be logically same, okay, otherwise it doesn't have a meaning. Then 75,000 and 60,000. Now the question is, this is important, multi-attribute ordering. So if I have two attributes, how it works, how it actually works. For example, select star from instructor, order by salary descending, and then name ascending. See, first I am doing salary descending order, and then name in ascending order. So which one should I consider now? So how it exactly works is, please try to understand here. First, salary descending. First you order by salary. So what exactly happens here? If I order by salary, I will get 90,000, 90,000, then 80,000, 80,000. This is for the first descending order, right? Now the question here is, there are two 90,000 and two 80,000. So 90,000 is Amit, and then we have Neha. Then 80,000 Riya and Karan. Now which one has to come first? Amit 90,000 or Neha 90,000? That is the problem, right? So second one is actually the multi-attribute ordering. The first order usually selects that column and then sorts it. But when there is a tie, if there is a tie in first order, okay, the first order there is a tie here, for example, then the second order is used. If there is no tie here, okay, if there is no tie here, then there is no meaning of the second column order by. Okay. Now if there is a tie, then I will use the second one. So if I use the name order by ascending, then Amit should come first. Amit, then Neha. So please observe the output here. It is not on the entire column. Ascending is not on the entire column. It is on whichever, suppose there is a clash between Amit and Neha, there is a clash because of the first column ordering 90,000, 90,000. So now to avoid this clash, okay, then I'll go for second order column order by. So here Amit comes first, so Amit will be displayed. Then not Karan, okay, it will be Neha between these two. Okay, first this 90,000 has to come and then 80,000. Then Neha is displayed. Then among these two, again 80,000, same block. Now I have to order by this. So Karan and then Priya. That is how multi-attribute ordering works. Hope you got it. You can also use expression and aliases. For example, select item quantity into price as total value from sales, order by total value descending. So what I am taking, I am multiplying these two and creating a new output column, total value, and then sorting by this decreasing order by this total value. So that can also be done. The next one important thing is the aggregate function. So there are some inbuilt functions to work on your columns. So some mathematical operations you can perform. For example, average, finding the minimum, maximum, sum, and then count. So these are called as aggregate functions in your SQL. There are 5 aggregate functions. Finding the average or mean of the column, finding the minimum in a column, maximum in a column, sum of the columns, count the number of tuples or rows in the column. So data type constraints, remember this, while sum and average are strictly limited to numeric. Because if I want to find a sum and average, I need numbers. Whereas minimum, maximum, and count can also be operated on character strings. Okay, minimum, maximum based on the some ASCII values or correlations. So what is syntax? Select name of the aggregation function and then on which column you want to apply that function from table with condition. The condition is not always mandatory. Select average is the aggregate function and salary column from instructors. So this will select what will give you only one final value. Will give you only one final value, average of all the salaries in that salary column in the instructor table. Select sum of credits from course, all total credits in the course table from credits table, credits column. Select maximum age from student. It will select from the column age, which is the maximum value. So for example, select average salary from instructor. So this is the column I want to find the average of. So it will take the average of this and then display the single value result. This one, if I want, I can rename. So average, select average salary as, say, I want to use some meaningful name, average sal. So here it will be displayed as average salary. I can use rename operator here also. Similarly, select some credits from course. So this is the credits column. I want to add this total 3 plus 4 plus 3. So 10 will be the result. Similarly, minimum and maximum. Select minimum age, maximum age from student. So minimum of age is 18. Maximum of age is 21. So that will be selected. This will be helpful in your group by. We'll see in the next video. Now, when it comes to count, the count has different variants. Please try to understand this. Again, when I explain the concept of null values in SQL, it's a very important video that I'll create in the next after the group by. There also I'll explain how each of these operators behave with null. Okay, so null is very troublesome everywhere in the SQL and database. Now, count can be used as count star, count column, count distinct column. Okay, so count star means everything, counts every row, including a row containing null. Okay, so for example, this is the have a column say C1, have some values 1, 2, 3, and null. If I apply count star, okay, count star, and then from this table, what will it will count all those. It will say 4 as the result. If I do count column, counts only row where column is not cell. If I say count C1 from this table, then it will display as 3. Okay. Then you can also use count distinct. Distinct means to remove the duplicates. Remove the duplicate count. Count distinct non-null values only. It will also not consider null values. So for example, select count star from student. So how many rows are here? So 3 rows. So 3 will be the output. Select count distinct department name from student. So I am counting the number of rows in this column, department name specifically I am mentioning, and then distinct. So CS is repeated twice, so it will only taken one CSEE. So 2 rows. 2 is the answer. So in the next video, we'll try to understand the group by and having. It's also very important concept. Thank you for watching. Please like, subscribe.